Now in this video we will learn about how we will find the solution of simultaneous linear equation in case of matrices. In matrices, when we have to solve two simultaneous linear equations, there are two methods. One method is called matrix inversion method and the second is called Cramer's rule. So first of all we will discuss about matrix inversion method, and for matrix inversion method I will tell you in detail what it is. For the proof of first method, which is matrix inversion method, in this case we will consider system of two linear equations in two variables x and y, and we will write its general form. Suppose in two variables x and y, and its general form of linear equation. We have learnt it before. First we will take as ax plus by is equal to m, any equation, and second we will take as cx plus by is equal to n. Now where a, b, c, d, m and n, they belong to real numbers, right? They are any real number: 1, 2, -3, -4, -6, -9, 6, 7, 8, any type of real number. So a, b, c, d, m and n, they belong to R. This system is called system of linear equations, right? Now we will discuss first of all how we will solve these two linear equations by using matrix inversion method, right? Now in matrix inversion methods, first of all I will write two linear equations in front of you, and then I will, here it should be d, not b. dy is equal to n, right? Now how can we write these linear equations in form of matrix? First of all I will write the matrix of constants, coefficients of x and y, right? Coefficient of x and y are, first is, I will write them in the matrix order: a, b, c and d, right? I will write the matrix of the coefficient of x and y like that, and then here second matrix I will write x, y in this case, and I will write the matrix of constant like that. So in first row I will write you will check coefficient of first linear equation, and in second row I will write the coefficient of second linear equation and its constant on the other hand side, and it will multiply by x and y like that. First x I will write in first row, and second variable I will write in second row. In this way we will write the two linear equations in matrix form. After that I will name them something like matrix form, because the name of the matrix is capital letters. So I will name this matrix as capital A, and this matrix as capital X, and I will take this matrix, I will name it like matrix B, right? Now after doing this, the next step will be I will write here now what will be the value of A or B or C or X. You will easily understand that A matrix will be our A, B, C, D. Our X matrix is as obvious, it's X, Y, and our B matrix is the matrix of constants, which are here M and N. So in next step we have to find the value of from 1. I will write this equation as 1. I have to find the value of variables, so I will put it here, and this will become A inverse B. The process is that A inverse is multiplied on both sides. When I will write it here for you, I multiply A inverse on both sides, right? A inverse and A will give me identity matrix, right? And identity matrix, whenever multiplied by any matrix, we will get the same matrix. And now if I will find the value of A inverse product B, then I will get the matrix X, and it will give me the values of variables X and Y. It's so simple. And how can we find A inverse? We have done previously. A inverse is equal to adjoint of A divided by determinant of A, and the answer is multiplied by matrix B, right? When you will find this, you will get the values of X and Y. So this method is called matrix inversion method. Hopefully you can understand. It's very simple, very interesting. Now the matrix A is A, B, C, D, and what will be its adjoint? Adjoint A will be, we will replace the diagonal elements. D will come first and A will become fourth, and we will change the sign of other remaining entries, right? This is the adjoint of A. Now what will be the determinant of A? You can find it here. Determinant of A we will find like that. What will be its answer? A multiplied by D minus BC, and it should not be equal to 0. Then we will proceed further, right? This is our determinant of A. Now simply I will put the values of adjoint of A, and adjoint of A is in front of you. This is changing the diagonal elements and changing the signs of other two. And our B is, I have told you earlier, it is Mn constants whole divided by determinant of A, which is AD minus BC. We have put it here. Now we will find the multiplication of the above matrices. It will give me, when you will multiply them, it will give you first M D minus Bn, and second will be minus Cm plus An, and it is whole divided by Ad minus Bc. Each and every will be multiplied by Ad minus Bc, which is our determinant, and again divided by determinant, and we will get X matrix, which is X and Y. So first will be the value of X, and second will be the value of Y, right? In this case you will say X value will be, it is in front of you, MD minus Bn over, and the value of Y will be So in this case we will find the values of x and y, and the value of variables we can easily find by using this matrix inversion method. It's very simple, you can easily solve the questions. And after doing this, the next what we will learn, that will be our Cramer's rule. So when you have to solve linear equation in case of matrices, we have two methods. One I have done in front of you, and this is called matrix inversion method. It's so simple. I have told you earlier what we will do. We will take two linear equations like that. We will make three matrices from these two linear equations. One matrix will be the coefficient of x and y, whatever the variables involved, and one matrix will be the of variables x and y involved, and one matrix will be the of constants involved, like that. Coefficients matrix here, whatever the sign, it will be 5, -1, -3, -4, whatever the value it will be, you will make the matrix of that coefficient of x and y. Then whatever variables are involved here, x, y are involved, maybe there are y or z or s and t, whatever variables in your equation, you will make the matrix of that x and y. And then on the left hand side, right hand side, there will be constant will be 1, 2, 4, 3, 18, 19, whatever, because they all belong to real numbers, and you will make the matrix of that constants. And then name these matrices. Though whenever we name the matrix, we will use capital letters. So for the first matrix, I will name it like capital A, and for x, y, which is the matrix of variables, I will call it capital X, and for the constant I will call it B. So if I will call them like that, then A will be like this, X will be this, B will be this. We have got this equation Ax is equal to B. Now I will apply A inverse on both sides. If I will apply A inverse on both sides, why I am applying A inverse both sides? Because I need X only here. Whatever is multiplied by X, I want to finish this. So to finish this A, I will apply A inverse on both sides. Now A inverse and A will give you identity matrix, and A inverse B will be here. Identity matrix multiplied by X will give you X, and here it's the formula become A inverse B. A inverse, you know, it's adjoint of A divided by A modulus. You will find this adjoint of A and A modulus like that, and just put the values, and after putting a simplification you will get the matrix X, which is x and y. First value will be of X and second value will be of Y. So it's very simple very interesting matrix inversion method. And after that we will do the Cramer's rule. Cramer rule is also very simple, very interesting. So in next video we will learn about Cramer rule, which is the method for the solution of simultaneous linear equations in matrices.